to stand better.
It's like it makes my morning a little bit like happier. Okay. I feel like I said let's go. Okay, so hey everyone. I know that yesterday we didn't really introduce our speaker because you guys already knew her, but from now on we're going to be doing introductions. So speaker today is another high school student from Louisville, and he does a lot of science research and has been really successful with his science research. So I think that, like, from what I've seen about Josh, he has a lot of deep interest and passion in what he does, and that's really important. Because if he didn't actually care about his work, I don't think that he or anybody else would be successful, right? So there's something called ISEF, Intel ISEF, which is like the International Science and Engineering Fair. Josh has been going since his freshman year. This year he won second place in his category. He can tell you some more about that, but he won, and he also won a scholarship by the Air Force, Navy, and it's pretty incredible all the stuff that he does. He does a lot of helping out in the community. He does something called science and social justice, which is really awesome in my opinion. So maybe he can tell you guys about himself.
Okay. Yeah, so I'm Josh Jacob. I'm a junior, or a rising senior at St. Anne's. And I did my research on 3D printing. And I didn't even know what 3D printing was until like 7th or 8th grade. And essentially, like, it was kind of weird how I got like familiar with 3D printing. And I went to St. Francis, which is like a small Catholic grade school. And in 8th grade, my school got a 3D printer donated, and it was broken. So I just, my friend and I kind of like tackled the problem and worked on it for a couple of months and learned how to like use the system. And that got me like really interested in technology, where I could see like all the applications that it had. But then we got to do a lot of hands-on, where trying to like solve the problem really helped us to learn about the technology. And ever since then, I've been trying to fix different problems with 3D printing, such as the lack of like multiple different types of materials. Because when you 3D print, you can mainly print like thermoplastics, which are pretty limited to what you can use them for. So, well, right here is a 3D printed prosthetic hand that I made. But one of the big problems is you can't integrate like metal pieces or even electronics into 3D prints. So what I wanted to do is to create a new type of 3D printer, which would be able to print metal for a lower cost. And that's what my research was on this year. And it's kind of built on the past technology over like my past 3 projects. Freshman year being like a simple, trying to print just a thermoplastic in a different fashion, like using a syringe. So what I was trying to do was use different types of extrusion methods, which are the way, like a 3D printer essentially is like a glue gun on a multiple platform. So it's kind of like, it just moves around, pushing down like plastic, melted plastic. And what I tried to do is create a new method which could, like, it's like a new type of hot glue gun essentially, which is like, it's called extruding. So here you can see like an industrial system, and this is a metal 3D printer, and it costs upwards of $40,000. So I wanted to create this metal, like a metal 3D printer, which would be less than $1,000. So I wanted to take this technology and kind of try to take a new approach, and I really got involved with that through reaching out to U of L, where they have this system, so I could kind of learn about the limitations with it, and just talking to people in the field really allowed me to see where I should try to implement my project. So this is a 3D printer I designed and built. It's essentially 2 3D printers combined into one, so it's like a desktop system. And what it does is it incorporates multiple different types of extrusion methods. So right here you can see this is called the hot end, and it's essentially the hot end, like a glue gun basically. And what it does is it heats up to like 200 degrees Celsius, and it can push plastic through onto the bed plate, which moves back and forth. And then the system moves back and forth this way, up and down. So it's like the 3 dimensions, allowing you to create certain plastic prints like this prosthetic hand. Like if you want me to, I'll pass this around if you want to see. This isn't a finished one, but you can see all the parts are 3D printed. But what my system was built for was for integrating electronics into the 3D prints. So what I did was, nobody's ever incorporated inkjet printing into 3D printing, so there was kind of a lack of software between the two, which would be compatible with both a 3D printer and an inkjet printer. So what I did was I created a novel device which would allow me to convert the signal from a 3D printing motherboard to the inkjet head. So right here you can see the inkjet head, which I would later use to print conductive inks. So I had to do not just designing the system like the mechanical side, but also the electronics of like the circuit theory, and then also the software and materials. So like my project is pretty interdisciplinary, and I think that's pretty important when you're like going into STEM, is to try to take into account like all different fields and how their approach can be like novel for your project. Yeah, so this is software is like really important. Like I've seen you all working on like coding websites, and this is just like a general outline of how my system works. But before diving into the code, this is what I did to kind of like map out how I would organize the system to communicate with each other. So what I did was, I guess like when you're programming, to try to like draw a flow chart, and that really helped me throughout the project to keep myself organized and also keep like the priority of how I would keep the system, like how I would organize everything. So drawing a flow chart really helps. Next slide. Yeah, so this is the system again. And the advantage is very cost effective, it's very low cost, and it can print metals at room temperatures, so you don't have to heat it up to high temperatures, which is associated with the high cost. And it can also print 200 centimeters by, or 200 millimeters by 200 millimeters by 200 millimeters. And it's applicable in many different fields, like in medicine, energy, rapid prototyping. So there are many different applications of the system. So it's scalable. So my system is unique in that it combines multiple printers into one. So they share bed plate. So my software supports adding multiple different gantries. So you can just create a really intricate 3D print by adding multiple different materials. So you could have like 10 different materials all in one 3D print rather than just 1 or 2 materials, which would be a plastic normally. So this can be used for like embedding electronics. Yeah. So there are a couple different parts of my project that I had to work on to create the system. So I guess one of the cool parts of my project was I 3D printed most of the major components of my printer. So it's kind of like a self-replicating device, and that most of the major, like all these white pieces are 3D printed. Here's one of the 3D designs of my extruder. So most of my system are actually 3D printed. So that was one of the constraints I wanted to keep in mind, was if you can 3D print the pieces, then anybody can like redesign it. So that's something that's really important to me, is like having an open source system, allowing people to kind of build on the project and then like therefore project, like moving the technology faster because everybody else can contribute to the project. So that's why I designed all the 3D parts for the system. So that's like the 3D model. And if you like ever look at like a 3D modeling software, which I'm not sure if you guys have looked at yet, but essentially what you do is you import it into like your model, and it's kind of like Paint, or it's pretty simple. But then you can take this and then just hit print, kind of like a document, and then it allows you to print it on the 3D system. So here's the 2 different devices I've created. The second one being what I ended up using, but I had to design the circuit in order to convert, it's actually converting a digital signal to an analog, or an analog signal to a digital signal, which basically that means the 3D printer sends like an analog signal, which is like a smooth and continuous wave, and the inkjet head can't use that signal. So I had to create this device in order to bump up like 12 volts to 20 volts, which is what the printer can use, and then also convert it to a different signal. And that's basically my way of solving like 2 incompatible technologies in order to combine them together. And it's also Arduino compatible, which is like a microcontroller. So that allows you to use it in many different applications, like beyond 3D printing. Yeah, so this is just hooked up to the 3D printer. So also, like visualizing how the system will print before actually printing was pretty important. This allows you to kind of like predict the future, like the end product. So this is just like my visualization of the code and how it would work in order to deposit the material. So I had to write a code, like a program to convert a normal 3D print into inkjet, how to like control an inkjet head. So this is like, if it has 12 nozzles, then I could indicate like print nozzles 0 through 7. So I could print 8 nozzles at once and then turn it off. So this is the way I could print using inkjet head on an open source platform. So next one. And here are some of the materials I developed. I worked to create a low-cost copper ink, which would allow me to print at room temperature. So I just inject this ink into my inkjet head, and then I can print that inside of the like plastic pieces in order to integrate electronics into 3D prints, which I would further explore the possibility of creating like flexible electronics, which is a very up-and-coming field. And there are a lot of different applications, such as like wearable devices, which are pretty cool because you can have like electronics embedded in your clothing, or I'm not sure if you guys have seen like the tattoos which can monitor your health, like temporary tattoos. So that's something that I'm trying to move my printing system towards. And you can see like in the lab setting, developing these copper inks. And also it's like a pretty approachable, like, so I've worked in this lab, it's at the Conn Center of Renewable Energy. For a part of my project, I reached out to the University of Louisville, and it's a good way to, like, if you have an idea, always reach out. It's really approachable. Like, you can always give somebody a phone call, and you'd be surprised how many people would be willing to help you out, like, if you have an idea. And a lot of the people there were, like, really helpful. So definitely don't be afraid to, like, reach out to others who are more knowledgeable than you in the field to get help. And that's definitely something that's, like, supported me throughout the project. Yes, and here's last year, in my previous research, I created a different 3D printer. But essentially, one of the things I tried to remove was anything that would prevent this from, remove technology which would prevent me from putting it in like a classroom setting. So one of the parts that I needed to complete my research last year was like an industrial intense pulse light. But I wanted to remove this system so you could have it like mounted on the 3D printer, and therefore allowing it to be like very low cost. So I took a low-cost strobe light, and I, like what you would use on professional lighting systems, or like taking pictures basically, and I mounted it in between the two systems so that it could cure like the resin and also the copper, because when you first print the copper, it's not conductive, because the nanoparticles are all separated. It's like a nanoparticle ink. So after you flash it with the light, then it turns like the copper color and is conductive. So that's one of the ways I like added a constraint to myself so that it would be below $1,000. So this is my software prior to printing like a circuit. I basically took an open source like GUIs, like a program which I don't know how much you guys have talked about like GUIs or user interfaces, but trying to get very simple user interface which would allow people to easily like go from printing their model or having an idea to printing their model. So this is like my platform, and then this is like a circuit prior to being printed. Yes, this is the printer again. So you can see basically the bed plate will switch in between the two systems, allowing it to integrate. So once it prints like a thermoplastic, then it can come over and then print the copper on top of that, and then print plastic again over like the circuitry, allowing it to have like embedded electronics or even in the future like energy storage devices. So I've also explored other like materials such as like graphene, which is the most conductive material in the world and has like amazing properties, but there are some issues with like, here you can see like there's some cracking, but essentially what I tried to do was to print like a hexagonal film. So this is like one step towards printing supercapacitors, which are basically like really powerful batteries, or they have like properties which allow them to like discharge really quickly, but they can't store a charge very long. So that's something I'm looking at doing, is using that for different devices, which I'm sure you guys have heard of like Tesla and like electric cars. So developing like very efficient batteries which can be integrated into a system would be very applicable in like self-drive or different electric cars. So, or can you go back? You can also see like this is the printed copper. I also want to have it flexible properties, so you can see me just like testing the like flexibility, and then looking under a microscope to see like the particle dispersion. And then I also tested like the connectivity of all my prints. So a lot of municipality would just be like an effective form of printing conductive traces. And here you can see the flexible electronics on like a PET, which is like a plastic film, and then testing like how accurate it was. Yeah, you can see this. Yeah, but I also tested like the resistivity and saw how it decreased as I increased the number of print passes, which would just increase the thickness. So I actually got it down to, once I printed 10 passes, copper wire sand gauge was very close to that of the resistivity of 10 passes. So this is essentially like the most simple print which I would want to do would be printing like thermoplastic housing, and then I can also print the thin film polymer using that syringe pump you saw earlier. And that like allows me to create waterproof circuits inside of the 3D prints. So this would be like the conductive circuitry. And this can be applied to many different fields, such as flexible electronics is a really big, what I'm going into, but it essentially can be used for like energy storage. So the University of Illinois has already done some research on integrating or printing like fully flexible lithium-ion batteries, like shown here. And you can see like all the different components of that battery. So my goal was to make a system which could integrate all these materials on the one substrate, allow me to create like flexible lithium-ion batteries. So basically printing them all in one like go, rather than having to like manually take each component and integrate that into the system. My goal is to try to have like a multi-gantry system which could basically just create this all in one go, like all in one pass, so it'd be fully automated. So it's using like wearable electronics, which would be really cool because what if you have like a flexible like smartphone or something that could just be integrated into your clothes, or even sensors which can monitor your health and then send that to your phone and let you know if there's like an emergency or if you're like showing symptoms like a heart attack. So those are some of the big like applications. And here you can see like a 3D. This is like an inkjet printed like theoretical print of what this is like a circuit which I could 3D print essentially. And also in like the biomedical field, there are a lot of different. So this is actually like a flexible pacemaker, and this is like a sensor which can be integrated on the heart. And this was done at the University of Illinois also, but they use a process which is called screen printing, and it's like all manual, and they like it's basically like squeegeeing it on a template. So it's pretty like a lengthy process in order to create these devices. So my system could mitigate that like length of time by having it all in a fully automated system where it can print multiple materials in any shape rather than just the template. So this is like the flexible pacemaker done by Rogers Group, and it essentially can keep the heart beating if it senses that the heart has like gone like cardiac arrest or any issues like that. And also integrating like power sources into any shape. So like that could be used for printing hearing aid shells, and then integrating the power source directly as like a crescent shape, making it more efficient. And also like just decreasing the size of batteries in general could be very beneficial for the medical field. So like in general, my system tackles a couple different problems, and it successfully combined multiple different 3D printers into one system. And also control like 3 different extrusion methods, which that's what all I tested, but it could also be scaled up. So this allows me to print multiple different types of materials beyond just like plastic. So we could potentially make like much more intricate hands, which could be used for control, like having conductive traces and being like fully powered. But also I had to keep in mind like the materials, keeping it low cost, because so silver is actually typically used in printing electronics. And that was one of my main reasons for using copper, which is like you run into issues with oxidation, and it's very limited. So that's something I had to work around to use the low-cost copper. And then also like in software, I combined 2 different known technologies in a new way, and it cost less than $1,000. And in the future, 3D printing has many different applications which are still being explored. So at the University of Louisville, they've done some really cool stuff with 3D printing. One of them being a very small kid. I think he was like like 4 months old, or he was really young. He needed surgery on his heart, and what they did was they took either a CAT scan, they took a CAT scan, and they took a CAT scan, and then they developed a 3D model from that, and then they scaled it up and printed it in like a flexible filament, and then they had surgeons go in and perform the surgery on this heart prior to going in on the kit. So it was like a non-invasive way to like plan out the procedure, which I think that's just incredible because it's like a life-changing technology, really, and it probably saved that kid's life. But also like it can be used in many different fields, like in history. So like the Science Center has a mummy, but they didn't know much about the mummy, and if they like unraveled the mummy, then it would like potentially destroy it. So what they did was they took a CAT scan and then they developed a 3D model from it, 3D printed the skull, and then they could identify features about it, which would like lead it to allow them to say like this is a female, how old it was. So this is like printed in resin, and you can see it's like really accurate. So the technology is only getting better, but there are a lot of different like ways it's going. So in the biomedical field, and if you go to the next slide, even in like fashion, you can like 3D print dresses and stuff. But also like Adidas just released some 3D printed shoes, which are pretty cool. So the sole is completely 3D printed. So they're actually doing some of that stuff at U of L with like Reebok or like snowboarding boots, making better, more like better footwear that's like built for each person rather than just like a generic pair of shoes. So if they like take a scan of your feet, then it'd be used for like people who just have like really odd feet, like if they're really flat or stuff like that. But they can also 3D print metal, which is incredible because this is titanium, and it's supposed to be like a small globe, but it can bounce really high. And this can be applied for like 3D printing hip implants and different like surgical pieces, which can be really helpful in the field because then you can like take a scan and then like draw it up so it fits perfectly for each patient, not just like a generic like hip implant, basically. Or like it can be like fully customized and then 3D printed in metal, which is pretty cool. And yeah, if you guys have any questions, feel free to ask. That's the end of my presentation.
Okay, so I'm blown away. I'm looking at all this stuff going, okay, how can a high schooler do, stuff like this, which you would expect like professional engineers that have like 30 years of experience in the field, that's the kind of stuff that you would expect them to do. So how did you get interested in this and how have you been learning? Because obviously, there's no classes that you can take and there's no like professor or somebody who can sit there and teach you all this stuff. So how have you gotten so much knowledge? How have you learned this much about this subject, which is not a subject that they offer in your school?
Yes. So it is like pretty limited, like even in like college classes to take like in really in-depth 3D printing. So one of the big things was not only like the internet, so like for some basic like programming stuff, there were a lot of different like websites, like Code Academy was really helpful in learning like the basics. And then as far as like developing the idea, just reading the news like really helped me like diving into like 3D printing news and following like where the limitations are. That kind of helped me see like where the niche idea could like come from, I guess. But I guess like it's built on itself. So like in 8th grade when we received like, it was a MakerBot. I'm not sure if you guys have heard of those, but it was just like a simple desktop system. And then just building up from working with that. And then my freshman year project was building like a new type of extruder. So it's not only limited to like learning from the internet, but also reaching out to like universities. So my freshman year, I didn't work with like University of Louisville or anybody. And then sophomore year, I emailed the rapid prototyping facility where they hadn't done anything with like 3D printing flexible electronics or like inkjet, but they had people who knew how to use like the systems to design like learning SolidWorks, which is like a 3D design software, or even like there's Tinkercad, which is very simple like CAD design software for designing the parts. So it really comes from like there's a lot of resources online, but also reaching out to like grad students or PhD students or even professors for learning the different parts. So like this circuits, that was really new for me this year, but I sat down with like a grad student who was working on a different project, and I just kind of like asked him questions about why he chose certain parts or what would he do in the situation. Really helped me to get through that portion, which was probably one of the most difficult parts of my project, since I hadn't taken any like circuit theory or even electronics classes at school. But just a mix of like reading online and then asking people at the lab really helped me.
Okay, so what are you planning on doing next? Are you going to keep on advancing this project, or are you doing something totally different?
Yeah, so I'm planning on advancing this project. It's actually my, last year I worked with like the materials more, and then this year I focused more on the system. But now I'd like to work on like actually applying this to different devices, so printing flexible electronics or sensors, which could then be like commercialized potentially, and just trying to create many different devices and applying it in different like trying to get in contact with like University of Illinois and try to like get a partnership with that. So I'm really exploring like the devices and trying to put like capacitors and energy storage, kind of like all the applications you saw. So I'm trying to like move into that field.
Obviously your presentation is awesome and your idea is great and it's basically fully realized. I'd like to hear about the mistakes that you made along the way.
Oh yeah, there's plenty of those. And that's actually like spending a lot of time on my project. It helped me, like I gave myself a lot of time to work on the project, and that allowed me to like kind of fight through like mistakes and also issues I ran into. So if you go back to like the copper ink slide.
Which slide?
It's like copper ink. So I ran into like a lot of problems. Actually, go to the printer slide. Like I started building the system, and like right off the bat, I made a really dumb like mistake. Like, so I measured all my 80/20s, and like I had it drawn up in a plan, but I forgot to add like 4 inches. So if you see here, like my system is off by like a couple of inches, and that really like took a toll. Like just a simple math error like kind of threw me off. And my system wasn't perfectly like how I planned it, like the dimensions. So that was like one of the first issues I ran into, and I had to like make up for that when I wrote the software. But also, this circuit really threw me on like a lot of problems since I was like just learning how to design circuits and electronics and integrating like ICs, which are like pretty small. I had to like go through multiple different iterations because each time I like shorted the circuit before that. So I really had to plan out and make sure, like do some very small testing before actually running the system. Because all of my mistakes were in that device, which prevented me from actually like doing my like half of my project of like inkjet printing. So that was like one of the big issues I ran into and big mistakes I made, and I had to end up like cutting a wire and jumping it, which is kind of like a sketchy way to do it, but it like sufficed for finishing my project and printing the inkjet. But it's not like a fully finished product because I had made that mistake. But also in like my materials, yeah, if you go to that one slide, the copper ink slide. Yeah. So if you see, yeah, right here. So copper oxidizes really quickly. Like silver, you don't really run into that issue because they've like done a lot of work on those inks. But with my copper ink, one of the first issues I ran into was after printing it, like hours after, it would start to turn green. It wouldn't be conductive, and that would be a horrible electronic device that just like corroded or even like oxidized really quickly. So what I did was I had to add basically it's like a hydrogen source. So I added a reducing agent, which would allow me to, like, it has excess like hydrogen, so that when it came in like contact with like atmospheric oxygen, then it would just produce water. So I was like, that was one of my first big mistakes, was I couldn't figure out how to like keep it conductive for like more than a couple of hours. And then also like so this ink is aqueous, so it's dissolved it's suspended in a like water-based solution. So you can see like all the particles, like in the top right, it's not connected. Like it's supposed to be like a solid square, but you can see like the individual droplets. And that was like one of like other really big mistakes I made. Like I couldn't figure out how to like, get it to print like a basically like a trace, so it wouldn't be conducted from each endpoint. So I had to add a surfactant, which allows it to have better droplets, and then create the conductive print. But those were some of the big issues I ran into, and mistakes I had to overcome. And also in the software, I'm sure Slum can tell you, you have to go through a lot of different tests of your program, and it's not going to work right when you first write it. So you have to really proof check everything and test each part before running the entire system. So that's really important in programming, is also proof, making sure each of your parts is good before you move on to the next. And that's my program, when I printed it out, was pretty thick, so it was a really long way to handle the system, and to go into each part was pretty difficult, but that's something you just have to do, and mistakes you have to overcome to create a successful system.
So I've been working on this project for a couple of years now, 3 years, but this year for this project, how much time have you spent?
I started in June, and then I initially planned on going to working on it 3 days a week after school, but then I just got really into the project, and I spent 4 days a week and then a couple of hours after school, so probably around 500 total, because I spent most of my summer working on it, and that's what I'm doing this summer also. Yeah, around 500 hours.
So I know you're a rising senior at St. X. What do you plan to do, after you finish high school? Where do you look forward to? What field do you want to go into?
So this year that kind of threw me to, I always planned on going to chemical engineering, but with this project, it's pretty interdisciplinary. So I've done mechanical engineering, different parts of mechanical engineering, electrical, materials, and software. So I don't really know. I'm probably going to go in materials engineering, because that's what really interests me most. But yeah, they're 3D printing is multiple different fields. So I'm just trying to figure out the best field to go into. It's moving the most.
So I'm trying to think of this in terms of overarching lessons that can be taken from this. So maybe someone's goal here is not to work with a super capacitor, but what's cool about it is that you took something on, you saw that there was a problem that existed, that for some reason you decided, because most people I feel are oh, yeah, can't put electronics on, 3D print, and they just move on with their life. Why did you, what motivated you to, I think I might take this on? And B, did you always feel like you could do it? Were there times when you didn't feel like you could do it? Just your whole, I guess more a soft skill, thinking about it in terms of soft skills, approaching a project and something that, I'm wondering, did it seem daunting to you? Did it seem like it was something you could take on? Did it seem like a goal that you could accomplish? Did you, what did you do when you felt frustration along the way? Was there ever points where you felt oh, there's no way I can do, this is beyond me? And
Yeah.
just your thought process as you walk through it.
So I guess first off, trying to create a new technology, when you really look at it, it's actually combining known technologies. So my project, if you go to the printer, it's not really a brand new technology. When you break it down, it's two known technologies combined in a new way. So when you're trying to innovate new products, it's really taking known technology. So this is just 2 normal 3D printers. And then inkjet printing, so you can print a document really easily, and that's that technology's been around for 30 years. And so is 3D printing, in an industrial platform. So my project, when you start a project, try to break it down into what known technology is already out there that you can combine in a new way. So it's really it's a blending of different fields. Inkjet printing and 3D printing, there's an issue with they can't combine. Their softwares are completely different, and the way they their signal is transmitted is really different for both of them. So just trying to combine them in a new way, but also trying to tackle that issue. I didn't just come up with this all in one day. It's really a process. So your end product is never what exactly you plan for. So like the different issues I ran into kind of formed my project. So last year I worked at the materials, and I didn't really know where I was going to go this year. Like starting like in May last year, I didn't know where I was going to go as far as my project after the science fair. So what I did was I just kind of like wrote down where my limitations were last year, and then if you identify the problem, then it kind of helps you to create a better solution. So like clearly like write down the issue that you're trying to tackle, and then break it down in different parts, and that really makes it more approachable when you go to solve the problem. Is knowing your problem very well, so you can like go in and like create a better solution. Is that kind of like answer?
Kind of, but also like your mental space, like how.
I maybe add to what you were saying yesterday. Yesterday, I was kind of talking to the girls about setting a goal and then moving the goalpost, right? So do something that you can do that you feel like you can do before you set your goal, your sights on the next goal. So maybe can you talk about it in terms of how you thought about it? So in a way that people are not very technical, right? So they may or may not end up going into highly technical fields. They're going to go into like some area, school, study, business, work. So how would you kind of take some ideas that you found worked for you and bring it into like, you know, like regular person, like I'm not an engineer. If you were to like tell me this is how I think you can be successful, how would you share that wisdom with me?
Okay, I guess like baby steps like are the big thing. So like trying to move forward like one step at a time. And one of the things that helped me with that is I have like a big whiteboard in my room, and what I did was I just wrote down very small goals that I could tackle each week or even each day, which would move me closer to my overarching goal. And just keeping that mindset is not like I need to build like a new type of 3D printer, or like I need to build this. Just kind of break it down, like I need to tackle a small issue. So like in my project it would be just printing one model which could be implemented. So like printing one piece, it's like all these block pieces. So really break it down, and then try to just tackle that goal, and then you know that you're already moving closer. And even if you run into an issue with one of those goals, you can do other stuff, or even try to like come up with new ways to solve that issue. Like for me, it's really like writing it down helps me to like, because if you try to like keep all your goals in mind, like you won't remember them, especially if you have like 23 goals for your project, or even doing anything in life.
So so I think that sometimes when someone gives a presentation and it's like you seem very confident, as you should, obviously you've done something really great, but sometimes as it's great to hear about how like people that like, were there times when you felt frustrated? Were there times when you felt like you couldn't do this? Were there times when you didn't feel confident in your work or in your goal, or that you could accomplish it? When you started at the beginning, how did you feel? Like, what was your like feeling about it? What made you think you should take this on, or even had the capacity to take this on? I kind of want to hear about like your struggle. Yeah.
Yeah.
More than like the concrete part of it, more the abstract, or like the struggle.
There was definitely a lot of times where I felt like I couldn't do it, but then like just telling yourself that you can. Like I know that sounds like really like that's hard to do, like easier said than done. But like I spent a lot of, I'm trying to think, especially like when you get closer to like a deadline, you start to doubt if you can get something done. But just like taking a step back and like taking a deep breath really helped, like to see, like put it in perspective and like see that an issue is really much smaller than it seems. And that was like really important for me, because it's really easy to like get lost in your work, and then like you get really into it, and then when like a small problem comes up, then it's like easy to get deterred. And like in my project, that came in when I had to learn, like when I was programming so when I was making the device, I felt like I didn't have anybody I could reach out to for help. But then when I just took a step back and then I like looked at other parts, I guess, like I'm trying to think. So I reached out to like a grad student and I just emailed him, and that helped me to like kind of solve different problems. But there was a lot of struggle to like dive into something that I'd never done before. But then overcoming that by reaching out to somebody who had done that, like, and I'm kind of talking like generally, but reaching out to an engineer who was more advanced than me in a certain field really helped me to dive into that technology and move past that like feeling that I can't do this, or just having somebody else there to like tell me I can, I guess, really helped me to get through the problem of like not thinking I could do the project.
Thank you. That was perfect.
Okay, I have 2 questions. So first, what was your support system like? And then second, what do you think that, what was like the differentiating factor between you, like a high school student doing this versus whoever else in the world has tried to do this and hasn't been successful? Like what made you successful?
Okay, yeah, so my support system, I kind of like, so my high school doesn't do like this kind of research, but reaching out and kind of forming your own support system, like if you don't have it readily available to you, or I guess it's like, help is always closer than you think. So for me, it was just like,
Say that again loudly and clearly.
yeah, like
Slowly.
help is always closer than you think.
I think that's my favorite line of your entire presentation. If you guys take nothing away from it, I would want you to remember that.
Yeah, like for me, you never know where you're gonna get help, and I was just talking to, like I went to a maker fair and I was just talking to like one of the professors there who had done like some 3D printing, and I ended up getting help from him to just go like take a tour of this facility, and like I was just like a freshman, and like you wouldn't think that like a professor would help out like a high school student, but when you show passion, that really makes other people want to help you. So being like passionate about like your whatever you're trying to solve or whatever you're working on really makes others want to help you and like form a good support system, like to be able to work more proficiently towards your goal, and like having people there to help you when you need it. So the second question is,
So
like,
what were some qualities that made you successful?
I would say just like being, like I'm super passionate about like the technology, and I think it has a lot of potential. So that was probably like one of the main driving, like, I guess like, you know, something that really drove me was the passion I had for the technology and wanting to get this technology implemented into like different fields, or I don't know if it's like too general, but like just having a lot of passion really sets you apart from other people, and like the drive, working diligently, not just trying to like, yeah, just get really involved with your project and like have a like good reason for wanting to do it. Like a lot of kids, like in science fair, like kids will do a project that they're not necessarily interested in, but it sounds really good. So do something that makes you like happy, or like do something that you're really interested in, and that'll like get you much further than trying to do something that you think others will like. Is that like?
Yeah, okay, so your project is obviously super interdisciplinary, right? You have to learn a lot of different skills. How did you push yourself to take the time to learn all of these different areas of engineering or science? Like,
really just like talking to people, because then you get like a better perspective by talking to people who are really good at that field. So for me, I'm not great at like designing circuits or electronics, but talking, so like I worked with a grad student who had gone to my high school, so we kind of like had that connection, but working, like just ask questions, like that really helped me, just like asking tons of questions. Thinking back, that's probably like the most important thing, is not just like towards your project, but like in general, like ask questions about the field that you're interested in or need help in. So like when you're like developing a website, you're not just gonna like go in and look it up, but like if you actually talk to somebody, like luckily like Sasan's here, or like somebody who's really good at like that technology, and seeking out the help from others who are really good at programming, like I don't know, I think that like is really important, is like asking others who are like very knowledgeable in that field about your like what you're doing. Is that?
So what was an opportunity cost for you to focus like so much on your project? Like what did you give up to make this happen?
Yeah, so this year, like I feel like I well, I guess like socially, like you kind of have to like take a toll. If you're like really into something, like you don't go out as much. Like that sounds like kind of cliche, but like there would be some Friday, like I'd work after school on like a Friday when I could go out with friends. But like I just got really into it, so like I guess that's one thing was like not being able to like go out with my friends as much. I mean I did, but like some, but like you have to kind of sacrifice what's like set your priorities, I guess. Like this was really important for me, and then also like I think that was the big thing. Like during the year, you want to like de-stress after like school or like on the weekends and just like hang out. But if you really get something you're interested in, it's like I had to give up like going out more, I guess.
And was that an okay thing to do?
I think so. Like,
Well, that's the thing, right? It's always okay to give up something for something else that you care about a whole lot more.
yeah,
So it's okay. You should give yourself permission to say, I can't do this right now, but I can later, you know, right now, this is what I've got to do.
I mean, I know from my experience it was a huge, well, there's always the question of like between achievement and passion. I know personally a ton of people who would do research for the sake of like awards and like ISF and SDST and all that. Do you think you would still do this kind of thing about like the framework of like applying for competitions and having all that?
yeah. So I've done this like I've really tinkered around with like I've always taken apart like my toys when I was younger, and like that's something I've done is just like tinker. And so in middle school like I didn't plan on doing like high school science fair, but then like I was already working on a project with like my 3D printer at home, and then somebody at my school had said like you should just enter, or like it was actually my middle school teacher. So that wasn't like the main motivation, and like with this project I didn't really gear it towards like a science fair because you can like form a project just for a competition, and that really like I think that limits you in some ways. So just working on something, like setting goals for yourself, like time-wise, but also like don't just focus on like winning an award, or like that's not the most important thing. It's like what you learn and like how you go about. I guess like the whole process is more important than like the journey is more important than like the destination.
So when you do projects like this, I mean, they end. Like there's a point where you move on to the next thing, right? So like, what have you been able to take away for the rest of your life? Like maybe for you as a person, or like for the rest of the work that you do. What?
So like I've definitely learned like a lot of technical skills, but I guess like the more important is like learning how to like dive into a topic that like is unknown, and then being able to learn about it, like push yourself to like learn rather than like that's the most important thing I think is to be able to dive into a topic that you're uncomfortable with and then come out being much better at it. It's like learning how you learn best and setting yourself up to be able to like have that environment where you can best learn like a topic or even like work most efficiently, I guess. Like how can you set yourself up for that success? And like yeah, I guess that's the answer.
So I know this project has definitely influenced you, and so looking forward in your career, like 5-10 years, where do you see this project helping you along the way with the work and the knowledge you learn?
Yeah, I don't know exactly where it'll help. Like, I can see like in the next couple of years, it potentially like affecting. Like, if I keep moving with it, it could potentially be implemented. But as far as like, I guess learning to keep things interdisciplinary, because like I know in college you start to like really focus in on like a certain topic, but trying to take into consideration like other fields where that could like be really beneficial, and not just like, I think that's something that high school students have like a leg up on, is you're not set in stone in like a certain major, so you really like have a lot access to like many different like pathways. So being able to just like combine different fields to create new technology, I think that's really something that's important for me to keep in mind when I like keep doing research. Or either one.
Okay, so how did this project perform at ISA?
So I like last year I placed first in engineering, and then this year I placed second in engineering. And like last year I went to a couple competitions before ISEF and didn't do like great. And I didn't plan on getting anything at ISEF. Like I don't know for iSuite, but I got like 30 at iSuite. So I didn't plan on getting anything like any awards. So that's like something like keep your head up still, because like you never know where your like work can take you. Like I didn't plan on placing after that. But just keeping your head up and like doing your best work, even like don't let your head like hang your head, I guess. Yeah.
So were there like, I know like overall like you said like you're really passionate about this, but were there any parts that like you just really like did not want to do or like were not really that passionate about within the project, and like how did you push past and like get that done so you could get to like your overarching goal?
Yeah, that's a great question. So I guess like one of the small things, like I'd never like done a really intricate like soldering job. Like it sounds really small, but like
What is soldering?
so soldering is like if you look at any circuit, all the like metal connections between the wires and like the actual board itself. So like on this, each component has like a pin, which you have to like take a. It's basically like a really hot stick, and then you like put some wire on it, melts, and then it connects it like the pins to the board. And that was just like it was pretty small scale, but like I had to do a lot of soldering, and that was just like really pesky for me. And it's really easy to get frustrated when you're like down working on really intricate like boards. And like I just had to keep in mind like the end goal, like to work, just push through this small part, which was really hard, like annoying to like reach the bigger goal.
So you said that you talk a lot like speaking to like people that like work at colleges or like were college students and stuff. People that like knew more about it than you did. Were there like times where like you like really felt like unconfident, really afraid to like do this stuff, and like if so, like how did you come past that? And if not, like what did you have that allowed you to do that?
So like as far as like getting in contact with people.
Getting in contact with people that like might have looked down on you, or might have like thought that like they weren't helping because you didn't know as much. Like how were you able to like do that?
So I guess like the first way to like get in contact with somebody is either like meeting them in person, like by chance, or emailing them. So I guess like in middle school, like we had a really good reason. Like our science teacher taught us how to email people like professionally, and that really like helped me get through like just being confident, like sitting down and writing somebody an email, knowing that they're either gonna be like really like nice to you, or they just might be in a bad mood. So it's not always you. Like you just want to go for it. Like there's not much you can lose from like emailing somebody. And like if you get rejected, then you get rejected. But just like send 100 emails, and like if one comes back, then like that might be your like best opportunity. So you never know. Just like try as many, like contact as many people, different people as you can, even if like other people, if certain people along the way don't like support you.
So if you weren't doing this, what do you think you would be doing? So what was another interest that you had that you decided to set aside for this?
As far as like different projects.
Yeah, just anything.
Oh yeah, so like also like freshman year I ran cross country and track, and that took up like a lot of my time. Like it was 5 days a week or 6 days a week. But then like I couldn't find the time for my research as much freshman year. So that's something I ended up putting cross country and track, and like I still run on my own, but I don't spend as much time on it. So I guess that's one thing I would be doing. But I guess like setting my priorities, like I knew this is what I wanted to go into in the future. So I thought like I wasn't a great like runner, but like I was okay. And I just saw like this is what I enjoy doing more, so I might as well like go into that. So I quit cross country and track after like freshman year, in order to work on like this kind of these projects.
So you spend so much time on this, how did you make time for schoolwork?
Well, that I would say like schoolwork would take like priority, but also like I would work on it like after school. But then if I had like too much homework, I would just work on that, and then really take the weekends to work on my project where I didn't have as much homework on like a Saturday or a Friday night. But it's really like having like a good balancing those two priorities, because like school would take priority, but making sure you find time for both is like super important. So just setting a certain amount of time you're going to work on it, and then even if you keep running into issues, like just cut it off at like if you're going to work from like 3 to 4 after school, then don't go past that time for like working on homework, I guess, like afterwards.
So I know you learn a lot of technical skills in a bunch of fields, but what soft skills did you learn, and what do you think you could do to help teach others those soft skills?
I guess like one of the big soft skills was like working in the lab environment, or even just working in any like maker space, is like be considerate of like others. Because when I had this set up at the Rapid Prototyping Center, and I'd always be around other people, so like grad students or PhD students, but just being like respectful and like keeping good conversation. I guess like you don't want to just be like really isolated working on something, but just be like bring something to whatever environment you're working in. Like just be joyful, I guess, and like try to not just ask questions and be a sponge, but also try to like help others when you see like you can help them out. So like yeah, that was like one of the big things was like one of the grad students was working on a project next to me, and he started working with inkjet. So we were kind of like bouncing ideas off each other. So just kind of like don't limit yourself to just your project. Like help others, but don't like overstep.
What was your favorite part of this project?
That's a hard part. Like I definitely think at the end, after you've like done a lot of work, it's really like great to see the outcome, but also like the people you meet along the way, like when you work in the field or even like in competitions, like as far as like working through it, like meeting all the people I did was probably the most enjoyable part. Because you meet a lot of unique people like along the way, like when you're working through a project or even just like working towards a certain goal, and I think that was probably my favorite part.
How do you think you can connect 3D printing and aspects of social justice?
So one of my big projects, at school I started the Science and Social Justice Club, which is like the main goal was combining those two. Like you can be a really good scientist, but not really like have a great impact. And so I go to St. X, and one of our big parts of our school is service. So I wanted to find a way to connect those two. So what we did was 3D print cross-head cans. It's like our first project, and we send those to kids in like Ghana. There's a chapter of, it's called Enabling the Future, which is like the nonprofit for 3D printing hands. So we connected with them, and that's one of the main ways I've connected like to technology, but also like using this for like education, like keeping it low cost so we could implement it in the schools, or even like different universities is like one of the main ways I wanted to like have an impact with this specific project, but also like moving it beyond, like using the technology for like printing water filters or just continuously coming up with like ideas like that for implementing it. But that was like probably the big project was 3D printing cross-head cans.
Receiver thank yous.
I think it was
Wait.
Yeah.
Yes.
How did your school react they learned about this project?
I guess like I think they were excited, but I also wanted to like get other kids involved. Like that was because like research isn't a big thing at like my high school, so I guess like trying to promote my project in a way that would help other kids get excited about research or see the possibilities of like what you can do doing a project, or even just like implementing science in the like social justice, or keeping that in mind.
I have one question that I think might be kind of helpful.
You know, when you go to school like manual, or if you do MST or something like that, a lot of people are kind of required to do science fair and research and so on, but you're in an environment where you're not required to do any of it, right? So not from a technical standpoint, but from sort of a social standpoint, how do you feel like, you know, you're sort of one of one, like there's nobody else like you in your school environment? How do you feel like about being the only person that does something completely different from 1,000 other people that are walking around in your building? How does that make you feel? And, you know, what is it that you can tell our young empowered ladies about what that feeling is, so maybe they can take something away from that?
Yeah, so I get, especially like freshman year, like when you're doing something that's completely different from like your peers, it's like pretty hard. And that was like really difficult for me, like especially my freshman year, because I felt like I didn't really like your place is pretty small because you're doing something completely different. So like a lot of kids are like big athletes, or like especially at St. X, like sports are a huge thing, but this like STEM is much smaller than like manual. Like so I was the only person doing like science fair research. And I would just say like recognizing that like it's okay to be unique and like to do what you love, but then also like socially, like finding kids who do stuff that's different from what you do is pretty important to like broaden your perspective, I would say. Like a lot of my friends are like into music or play sports, and I still have like friends from like manual who do stuff that's similar to me, but also like reaching out to others and like, yeah, don't limit yourself, or like just say, okay, I can like isolate myself because I don't belong here, because you're doing something completely different, but just like try to reach out and just get involved. Like especially in my school, like trying to start the initiative to like build the STEM program was really important to me once I saw the shortcomings of like not having it, I guess. But yeah, that was really difficult for me like freshman year and like in the sophomore year, but then like now I feel completely fine. I try to like build that environment to support others who might be interested in my school because we don't have it as much. Does that like get